For you to really learn about Java, you're going to need to do more than what just the assignment is. So this whole little lecture here, this whole little mini discussion is not about specifically the homework. You're going to put together the homework and we'll talk about that separately. But this is the type of thing that I think you should be doing to really get familiar with Java and be successful in classes going forth, because there'll be things that they're going to ask you to do that you might not have done explicitly in the assignments right now. So I'm starting here. I'm right clicking over here in my Eclipse space. I'm hitting a new Java project. I'm going to name this decisions for lack of anything else to call it. This is what we're going to work on right now. And in the source, I'm going to create a new class, which then can also be called decisions for lack of anything else. And I'm going to put a main method inside of here to get started. If you remember, I hit Control Space after typing the word main, and in Eclipse, doesn't do it in all tools, like NetBeans won't do this, but it'll give you the option to create a main method, and it pops all that code out there for me. Notice I'm putting my curly brackets on the next line. This is something that I just prefer to do, and I haven't configured my NetBeans environment to do it otherwise here. This is my new NetBeans environment when I installed it, and you have to go through and configure that and set that up, but that's the subject for a different lecture. All right, so the basic decision statement is the if statement. So I can put a system dot out that print line right here, and really simply I'm just going to do the number 1, just print out the number 1, and then I'm going to copy this and paste this and put out the number 2, and then copy and paste this and put out the number 3. And so we code small. That's one thing I want to teach you, is to code small. Just do things that you think work. If you don't know how to do a system out.println, then just do one of them before you copy all 3 of them. Because if you do something wrong, like you do sysd, and then you copy and paste that over and over again, and let's just say you did in all 3 places, you would be perpetuating these errors, and you have to go fix them in many places. So if you see any red text, get rid of it before you continue. All right, so now that I have this, let me just say 1, 2, 3. You see that my output down here, I hit the run button up here, and my output was 1, 2, 3. Now let's say I want 2 to do conditionally. So if, I don't know, let's just say false, just to start with, then I'm going to print 2. And so now when I put that around there, this code's going to work because I wrote it cleanly, but you see it's now 1 and 3. So if false means something's not going to happen. It's never going to happen because it's not true. The decision only goes forward when it's true. Notice here I have curly brackets. I should align it so this is hidden inside, but I don't have to. Java, as long as it's between curly brackets, it can be indented inside there however you want to. So again, 1, 3. It doesn't matter either way you did it. Let's say I did not have curly brackets here. We talked about this in lecture, but it would work exactly the same way, 1, 3, because there's 1 line of code inside of here. Notice now, if I take the line 3 and I indent it here, it still says 1, 3. The indentation means nothing as far as Java is concerned. It's the curly brackets that matter. If I wanted it to be 1 and then 2, 3, at this point it would just do 1 because the curly brackets circle around both 2 and 3. If I want 2 to be conditional, then I can leave the, you see it's indented a little bit funny here. It still prints out 1, 3. This indentation means nothing. But hopefully you can see how easy to read. I have a class. Inside that class I have a method that gets indented 4 spaces, and then the code that is in the body of this method is indented 4 more spaces, and when I have the stuff that happens inside the if statement, it gets 4 more spaces. So I'm hopefully making this highly readable inside of this approach. And then now I'm cleaning up that extra line. That's it right there. Keep it nice and clean. I like clean code. It keeps my organized mind going. It lets me see things quickly, identify things quickly. The structure, the patterns, help form in my mind, and I think that's something that could be helpful for you too, as opposed to code that looks maybe like, oops, sorry, my keyboard here. Code that maybe looks like this. This can be harder to tell what's going on because what's the structure of this code? By the way, if you are coding like this just because of you're trying to figure it out and you say, how do I clean this stuff up? You can always right click on this stuff and there's a source right here, and then there's a format, or you can hit Control Shift F, and that will actually bring it back up and format all of your source code based off the rules. I don't use it too often until I fixed it because it puts my curly brackets on the same line. I like my curly brackets on the next line, but at least you can see here it will give you that indentation and make it nice and clean. Oops, and this E is an error. So let's look at this error real quick. What's it say? It says E cannot be resolved to a variable. It thinks there's a variable. It's not there. If I just pick one of these random things inside of here, then what could happen is I could really screw up my code because I don't know what it is. If I do this, it just creates object E, and I don't know what this means, so I don't want to do that. I only want to use those things. Mostly I just want to fix them by hand at this point. All right, so we're a little bit all over the board, but let's come back to where we were. So the syntax of the if statement, again, the if, the parentheses, and then some decision inside. I can do if true, oops, not capital T true, lowercase t true, and then all three of these would print again, and the if statement is essentially useless, but you can see I have 1, 2, 3. If I go back to false, I'm hitting Control Z right here to fix that. Let's say I put a semicolon at the end of here. We talked about this as well, just all the little things on syntax. If false with a semicolon, if I run this, oops, save and launch, sorry. If I run this, I have 1, 2, 3. Even though it says false, this is still printing out. Now, why is this still printing out? It's because that rule we just saw a second ago. When I put this here, this is the equivalent as saying this right here. All right, we wouldn't write this code right here, but that's the same thing. This, it compiles the same, it runs the same, because that semicolon does not belong at the end of an if statement. I am allowed to, in Java, create a block. That's what this is called here. Anything with an open curly bracket, closed curly bracket is called a block anytime I want to. So I have to be really careful about where I use semicolons, or the code looks like it's behaving the way it's supposed to, but it's not. All right, let's go a little bit further here. This true false can be a decision. I could say if 2 plus 2 equal to 4, right? So 2 plus 2 equal to 4. I can run this, and then that's true, and that's going to come up. I could say 2.2 is greater than 4. Okay, is 2.2 greater than 4? Well, no, it's not. 2.2 is equal to 4. I'd have to say, if I want this to be true in this case, I can say 2.2 greater than or equal to 4. And then that goes up true. But this isn't very useful because 2.2 and 2, this is constants. That's the data that's interesting. I can say, sorry, I keep it in my caps lock. Int, let's just call it first number is equal to 3. And second number is equal to 4. And I can say if first number times second number divided by 3, now let's just say divided by 2, oh, I'm sorry, you know what I want to do? I'm going to show you another operator called mod2 is equal to 0. All right, so 3 times 4 mod 2. Let me run this and I'll explain what that does in a second. So you can see it, excuse me, it prints out 1, 2, 3. 3 times 4 is 12, right? When I say mod 2, I'm saying divided by 2. When I say divided by 2, then what I have, 3 times 4 divided by 2 is equal to 12. But mod is what's called the remainder function. So 12 divided by 2 is 6 remainder 0. If I make this instead 3 times 3, then this will suddenly not show up anymore. So basically what this is saying is I want even numbers. So 3 times 3 is 9. So first number times second number, so the product of two numbers, if it's even, that's what mod 2 does, then print out 2. If it's odd, don't print out 2. And so the mod operator, what happens here is I have, and this will just do some comment right here, I have 3 times 3 is equal to 9. And so 9 divided by 2 is equal to 4.5, right? But this is integer math. So This is all comments. So it's actually 4 remainder 1. And so mod, which is this guy, is the remainder. So in our case, it is either 1 or 0, because that's everything divided by 2, either as remainder of 1 or remainder of 0. Either it's divisible by 2 or it's not. And that's one little trick inside of here. But the point I'm trying to get at is this right here is using variables. Those variables could be passed in from the user. Those variables could be passed in as a parameter. They could be something you go ask the user to go get. You go prompt the user to go get those. Those are all things that can be fed into, and I can make a decision upon. You can say I did greater than, less than, I did equal to something. In this case, I'm using mod and equal to something, but that gives me my if statement. All right, so in this case, I can say instead of 2, this could say it's an even number. And if it's not an even number, I can say else. Oops, sorry, I did that already. And I'm going to bring number 3 inside of here. I'm going to change this to be, it's an odd number. And so now when I run my code, you can see it prints out 1, and it's odd, because it's 3 times 3. If I make it 3 times 4 again, then you can see it changes to even. Because my syntax here is if and else. And so when this is true, then it does this work. When this is false, it does this work down here. You can expand on. I'll leave it to you to play with if then else statements as however you wish. At this point, really my focus for you is the syntax. I want you to play with getting your curly brackets straight. I want you to play with getting your parentheses around there straight. I want you to get some basic logic going on. I want you to break your code on purpose. Leave out a semicolon and see a curly bracket, excuse me, and see what happens. Syntax token error that has an extra close, so you have to delete one. And so what you could say is I'm going to delete this one here, and then so my formatting's all goofy. So what ended up happening was this one should go here, this one should go here, and that's because my else statement works on this one right here. So it compiles okay, but that's not really what I wanted to. Let's just, so the point being of this, your time to play, is to see what the error messages are. If I did this, it's not going to give an error message, but it's also not going to behave as an else. It's going to say odd, and if it was even inside of here, let me get a 4 inside, it's going to say even odd. You say both of them, because this is not an else branch without the word else inside of here, for instance. So again, this is your chance to go back and play, ask any questions you have. This week's assignment may or may not stretch you much on using this decision logic, the if statements, but you can play with it as you want to and use it as you want to. You will need it eventually. You will be playing with it eventually. So now's the chance to practice using it so when you're familiar when it comes out later on.